All right, in this example, we have a colony of insects initially has a population of 100 insects, and if there are 250 insects after 12 days, and let's go ahead and answer some questions. So just to point out here, initially we have 100 insects, and then after 250 days, or sorry, after 12 days, we have 250 insects. Okay, so let's see here, part A. Let's go ahead and find the growth rate. So in order to find the growth rate, I'm going to go ahead and write down my formula. A of t is equal to a sub 0 times e to the kt. So we're trying to find k here, at least first. So first, find k. So that's our goal on this particular problem is we're trying to find the growth rate. We first want to find k. And the way I'm going to do that is I know for a fact after 12 days, so if I do a of 12, a sub 0 I know initially at 100, e to the k is what I'm trying to find, and the only thing I know anything about is after 12 days, so I'll plug in 12 for t. So after 12 days, we know we have 250 insects, so that is a of 12. So I'll plug that in on the left-hand side. Right-hand side, I'll just rewrite 100 e to the 12k. And now I'm trying to solve for k, so I'm going to go ahead and divide both sides by 100. That'll leave me on the left. Let's see here, that's a 2.5 there, it looks like. And then to get rid of the e, I'm going to take natural log of both sides. I want to do that because the right-hand side, natural log and e, will cancel each other out. And let's see here, natural log of 2.5 is going to be equal to 12k is all I have left over now on that right-hand side. So to get k by itself, I can go ahead and divide both sides by 12. Now here we're going to need a calculator for this section, word problem section. We're going to need a calculator. And I get approximately 0.076 there for k. Now that is the growth constant. In terms of the growth rate, I need to change that into a percent. So this is the growth constant. And to get the growth rate, I'm going to make this 7.6%. That'll be my growth rate, which is what I was looking for on part A here. All right. And then let's say for part B, I want to know how many insects will there be after 30 days. So how many insects will there be after 30 days? That means I'm trying to find a of 30. And now, let's see here, I know that 100 was the initial e to the, now I know what k is. K is equal to 0.076. And for t, I want to plug in 30 in this case. So let's see here, we had a sub 0 e to the k t there. So now we know k, so we can go ahead and plug in any value we want for t and actually figure it out. Again, this is a calculator problem again. I'm going to type in 100 e to the 0.076 times 30 into my calculator. And for that, I end up getting approximately 978 insects. If you're having any trouble with your calculator getting these values, please come to office hours, please talk to me. And then part C, I'll tack on one more part here. When will the insect population reach, let's say 2,000? So in this case, I want to know, okay, when is this future amount going to be 2,000? So in this case, I don't know the time value, and that's what I'm trying to find here. So I know I want it to be 2000, I know I have 100 to start with, and on part A I found 0.076 for the growth constant, so I have that plugged in for k there. In order to solve this, I'm going to divide both sides by 100, that'll give me a 20 on the left-hand side. And then I can go ahead and take natural log of both sides to cancel out the e. Canceling out the e is definitely necessary here because I'm trying to solve for t. Now, t is just being multiplied by 0.076, so I'll go ahead and divide both sides by 0.076. That'll leave me with t by itself. I can plug that into a calculator. Got 39.42 there. Just check my math lab, see what it wants you to do. If it asks you to round to the nearest day, let's go ahead and say 39 days. And when it has you do that, it literally just wants you to round. It doesn't want you to think about, it doesn't make more sense for the nearest day to be 39 or 40 in terms of this question. It just wants just regular rounding. Round down if it's not 0.5, round up if it is.